Hello student, this is your professor Dr. Vaibhav Pandit, Assistant Professor, School of Agriculture, SR University, Warangal. Today we will about remote sensing and GIS, its application in agriculture. What are the advantage and disadvantage? How remote sensing is useful for the agriculture and predicting the different phenomena in the agriculture. So let's we'll start this topic today. So we'll start with the basic understanding about the remote sensing. What is the remote sensing? So if you will see the basic idea about the remote sensing or what remote sensing is the. So remote sensing is the just collecting the information about an object without any physical contact. So that is called remote sensing. But if you see the some good definition, that is the science and art of acquiring information about an object or some area without being a direct physical contact, by detecting or measuring or the emitting the electromagnetic radiations. So whatever the sun radiation will be there, so using that radiation which will fall on the objects, so that emitted radiation we will have to use to acquire the information about the particular object. So if you will consider in a simple language, it is the uh, observing the earth from the long distance using a sensors, that is called the remote sensing. So there should not be the any direct contact with the object, there should be some distance, like that. That is the called remote sensing. So the remote sensing started uh, in the USA. So the Evelyn L. Pruitt, known as the father of remote sensing, who have contributed to the development and application of remote sensing. In India, PR Pishoroti, known as the father of Indian remote sensing in India, because he's used the remote sensing application in meteorology, even in agriculture also. So, what is the basic principle of remote sensing? So, remote sensing is based on the interaction of electromagnetic radiation with the earth or with the object. So in there different steps will be there, like some energy source will be there, then one traveling atmosphere will be there, then object will be there, the reflected radiation which will capture by the sensor, and the data we will get, that will we will present in the form of image. So we'll see this component in one by one and how it will interact with the object. So these are the component, like first one that is required most important is the source. So source, here the passive source is the sun, and active source that will call the artificial source, that is radar and lidar. So sun is the passive and most important source for the uh, remote sensing. So without source, the remote sensing is not possible. So what is my source? The substance or the point who will emit the radiation. The next component, that is the atmosphere. So atmosphere, the sun radiation will pass through the atmosphere, and we know that the atmosphere will have the gases and suspended particles. So that suspended particle and gases which will absorb and scatter the sun radiation. So after that, after passing through the atmosphere by scattering and absorption, so some amount of radiation will go into the onto the earth, and it will interact with the different object like soil, water, and vegetation. And after interacting with the object, that particular object will reflect the some types of the radiation, and that radiation, the one sensor will detect. So whatever the sensor will be there, so that sensor will detect the reflected or the emitted radiation from the target, and each target will have the specific signature of reflected or emitted radiation. So that's why we will able to identify the target and object based on the reflected radiation which will detect by the sensor. Next one will be the platform, that is another component where the sensor will be mounted. So and satellite will be there, on satellite sensor will be there. Then aircraft we will use as a platform, and drone. So platform is a physical mode used to mount the sensors, and last one is the data processing system, which will convert the radiations or spectral radiation or emitted radiation, which will capture by the sensor and will convert into the images, understanding images. So these are the components of the remote sensing, and this component we'll see in the details. So before understanding the components and the different types of remote sensing, let's have the focus the how the radiation is important or major, or do the remote sensing part, because it is the first requirement of remote sensing, that is the electromagnetic radiation. So what is electromagnetic radiation, which is the first requirement of remote sensing? So it is the source of energy which illuminate the target, and this energy is in the present in the form of electromagnetic radiation, and all the electromagnetic radiation will behave as a wave as per the theory of wave. And the electromagnetic radiation will have the two field, one is the electromagnetic field and another one is the magnetic field. So the electromagnetic field which varies with the particularly perpendicular to direction in which a radiation is traveling, and its magnitude also varies from the distance to distance, and the magnetic field which is against right angle to the electric field. So both this field travel at the speed of the light. And the two basic characteristics of electromagnetic wave which is important to understand the remote sensing, that is the wavelength and frequency. So wavelength is the heart of remote sensing. Without wavelength we cannot understand the remote sensing, because this is only the important, this is the DNA of the remote sensing. Wavelength means collection or detection of wavelength. This is the called DNA of remote sensing. This is how wave will move. This is how radiation will move. So this is called the wavelength, two consecutive crest, and frequency means one, per second how many times it will, per second how many cycles will complete. That is called the frequency. So wavelength is the length of one cycle, which can be measured as a distance between two consecutive wave crest. That is called the wavelength, and it will measure in represented by the Greek letter lambda, and measure in terms of meters, nanometers, micrometer, then centimeter, and frequency is the number of cycle in fixed distance or fixed point over a period. That is what frequency, and it is measured in a hertz. Measure in a hertz. Then what is electromagnetic spectrum? So electromagnetic spectrum is present in the electromagnetic radiation source of energy. So it will have the wavelength, shorter wavelength and longer wavelength. Shorter wavelength is the gamma or X-ray, and the longer wavelength, that is the microwave and broadcast radio waves. And we'll have the different electromagnetic spectrum which is used for the remote sensing. There are not only the one types of remote spectrum, so we'll have the different types of remote spectrum used for the different types of remote sensing or identifying or measuring the different phenomena. So most important electromagnetic spectrum or the region in the electromagnetic spectrum is the UV region, that is ultraviolet region of the spectrum, which are the shortest wavelength and which are the practical important for practical remote sensing. Okay, and this radiation just beyond the violet portion of the visible wavelength is called visible wavelength. And the light which our eyes can sense, that is called remote sensor, can detect is our visible portion. So detect is a part of our visual portion. So it is important to know how the small visible portion is related to the rest of the spectrum. So there are a lot of radiation will be there around us, which one we cannot see. So which one we will see, that is called visible portion of the spectrum or the visible radiation, and which one we will not see, that is invisible radiation. But which one we will not see, it not means that it is not available. So that invisible radiation we have to detect by a different instrument like the spectrophotometer instrument, and which have its own different advantage. So one is the visible portion or visible spectrum, which is start will have a different wavelength which start from 0.4. Visible wavelength cover range from zero point 0.4 to 0.7 micrometer, and the longest wavelength that is the red, and the shortest that is the violet. So some are the common wavelength we will see here, and which color will form when it will pass through the prism. So violet color wavelength that is 0.4 to 0.446 micrometer. Blue color wavelength 0.446 to 0.500 micrometer. Green color that is 0.5 to 0.578 micrometer. Yellow that is a 0.578 to 0.592 micrometer. And orange that is 0.592 to 0.62 micrometer, and red wavelength that is zero point 0.6 to 0.7 micrometer. So these are the parts of visible spectrum. So these are the colors present when it will pass, when the radiation will pass through the spectrum. That time we can observe this visible wavelength. So in that visible wavelength, three are the important and primary wavelength or colors, that is the blue, green, and red. So they are defined as such because no other primary color can create it from other two. So all other colors can form by combining these three red color, right? So that's why is the primary colors. No other two primary color form a third, but other colors we can form by using this primary color. So primary colors are the blue, red, and green. So we see the sunlight which have the uniform and homogeneous colors. It is actually composed of different and wavelength radiation. So it's primarily the ultraviolet, visible, and infrared portion of the spectrum. Then the visible portion of the radiation can be shown in a component of color when the sunlight will pass through the prism, which is bent when the light is different amount of according to wavelength. The next portion of the spectrum on which we are interested, that is the infrared radiation, which cover the wavelength 0.7 to 100. So the wavelength of infrared that is 0.7 to 100 micrometers. Infrared regions are divided into two categories. So one is reflected infrared and emitted thermal infrared, emitted or thermal infrared. Radiation in reflected infrared region is used for the remote sensing purpose. It's almost similar to the visible portion. The reflected infrared wavelength, which range from 0.4 to 0.3. This is the reflected, and the thermal infrared region, which is quite different from the visible and reflected, as this energy is essential as the radiation that is emitted from the Earth's surface or the different bodies from the are different bodies present on the Earth's surface, and this emitted or thermal infrared regions which is released from the object only when the object it get heated, and it will release in the form of heat, and the wavelength of this radiation is 3 to 100 micrometer. And the most after this infrared region, the most important uh, spectrum which is required or important for remote sensing, that is the microwave regions, where it start from 1 mm to the 100 1 meter, which cover the longest wavelength for use for the remote sensing. So this is the electromagnetic spectrum. Shortest wavelength is gamma ray, then X-ray, then ultraviolet light, infrared, then radar waves, microwave, then television, and radio microscope. This is a wavelength for particular region. So gamma rays is less than 0.01 nanometer, that is used not used because it's harmful. X-ray is for 0.01 to 100 nanometer, not used for the remote sensing. Then ultraviolet we have seen 0.1 to 0.4, which have the limited important related to only atmospheric studies. Then visible rays, that is radiation 0.427 micrometers, which one will see by human eyes. Then infrared will have three different uh, components, that is near infrared, short wave infrared, and thermal infrared. Near infrared range is 0.7 to 1.3, which is used for vegetation analysis, and 1.3 to 3 micrometer, which is used for soil moisture mineral at detection, and a thermal infrared which is the 3 to 40 micrometer, used for the temperature heat measurement, and the microwave, and most important, the wavelength is 1 mm to 1 meter. So these are the different regions present in the ultraviolet ultramagnetic spectrum. So we'll see when the remote sensing and the radiation which is uh, passes through the atmosphere, how it will react with the atmosphere and the earth. So before radiation used for the remote sensing, which is reached to the earth surface, it should travel to the atmosphere. So there are some particle gases will be present which affect the incoming radiation, or we can say the light, and this effect caused by the scattering and absorption. So scattering means when the particle or the gas molecules present in our atmosphere, which is interact with and cause the electromagnetic radiation to redirect its original path, and this is happen when the particle is large size, small size, or equal size. And how much scattering takes place, it depends on the several factor like size, then abundance of the particles, and the wavelength of particles. So nearly there are three types of the scattering we will see. Uh, this is a Rayleigh scattering, which is occur when the particle is small compared to the wavelength of radiation, and my scattering which occur when the particle have the same size as wavelength of radiation. And final scattering mechanism, that is called a non-selective scattering. This occur when the particle are larger than the wavelength of radiation, like water droplets and large particle, which cause these types of scattering. So non-selective scattering get the name from the all the wavelength that is scattering, but the types of the scattering cause fog and cloud to be appear. Then absorption, that is another mechanism in the electromagnetic radiation will interact with the atmosphere. It is opposite to scattering, and this phenomena cause the molecules in the atmosphere to absorb the energy from the various wavelengths. The scattering mechanism important is called non-selective scattering. The area of the spectrum which are not severely influenced by the atmospheric absorption, and that is used for the remote sensing, that is called the atmospheric window. That is called the atmospheric window. So atmospheric window means the radiation by the after the absorption. So radiation there, it will interact with the atmosphere, and those will not interact. It will go directly to the yeah, directly to the earth surface, and that radiation is called atmospheric window. So if you see, these are the absorbed portion by the, this is absorption. This dark color we will see, this dark color, this is the, this is the absorption in atmosphere. So this is the absorption atmosphere, and this area is the empty area. This is called atmospheric window, means it will reach to the earth surface. So this it is reaching to the earth surface. So dark color, it is absorbing in the atmosphere, and it is coming to the earth surface. So by comparing the characteristics of two common energy or the radiation source, earth and sun, with atmospheric window available to us, we define those wavelengths which can mostly effective for the remote sensing. And when the radiation which is not absorbed or the scatter in the atmosphere, so that will reach to the earth surface and interact with the different objects of the objects present on the surface. So when it will come to the earth, there are three forms of interaction we will see with the target or the object present on the surface. First one, that is the transmission. First one, the absorption. Second one is the transmission, and the third one is the reflection. The total amount of energy when it will interact with the surface of the object. So one or more of the three ways it will interact with the object. The portion which depends on the portion of each which depends on the wavelength and the material and the condition of the features. So reflection occurs when the radiation bounce off the target and is redirected. In remote sensing, the most important interesting measuring the radiation that is the reflected from the target. So we refer two types of reflection which is represent two extreme end of the wave in which the energy is reflected from the target. So one is the specular reflection, another one diffuse reflection. So surface is smooth and we will get the minor like reflection where all the energy is directed away from the surface in a single direction, and that is the specular reflection. And diffuse reflection occur from the rough surface where the reflected almost uniformly in all directions. That will diffuse reflection. For any given material, the amount of solar radiation that is reflected, absorbed, transmitted, or emitted varies wavelength. When the amount coming from the material is plotted over the range of the wavelength and the connected the point to produce the some graph, and that's called the material spectral signature. In the general example, you see the spectra reflection against the some of the object that is vegetation dominating the you will see in this is the spectral signature for particular vegetation. In this vegetation graph, green color, this is the dry soil and this is the water. If you see the reflection, based on this only we will identify what is the object present on the earth surface based on the reflection of the different types of wavelength. If you see the vegetation here, the from 0.4 to 0.5, there is a small reflection at 0.6, 0.5 point. There is a large reflection in green color because reflection of green color indicates that the chlorophyll is present, and there is a sudden absorption of red color vegetation with the red color wavelength. And infrared radiation still increases, so it somewhat decreases the wavelength near infrared because the tissue will be present internal structure. So again at the 1.2 micrometer again there is decrease. So it is large diffraction we'll see at 1.4 because the internal structure again it will increase, and again it will decrease because of moisture pressure in the vegetation. So this is the spectre and this is the particular graph against the reflection at various wavelength. This is called spectral signature. So this spectral signature is not same for the all objective. It will varies from objective to objective. For example, if you consider the soil, you will see the soil spectral signature. It is the reflection is high and it's increasing. But in a wet soil, if you see, the reflection is small compared to dry soil because of presence of moisture along the all wavelength. The reflection is less compared to dry soil because absorption of the radiation is more. And if you see the water, because absorption is more blue color and there is no reflection around 0.8, after that there is no reflection in infrared region. And where the somewhat the turbide river was water there, so we can see sometimes of the reflection, infrared reflection, other at 1 up to 1, after that there is no reflection, only absorption of the wavelength. So like that we will study the objects, and we'll see the we will identify based on the spectral signature only what object and how much and what kind of object. Then what are the types of remote sensing? So based on the source available, so there are two types. One is passive remote sensing, another one is active remote sensing. So passive remote sensing will use the source, that is sunlight, which is the natural source, and sensor detect the reflected and emitted radiation from the object. Means the sunlight, reflected sunlight and emitted sunlight radiation coming from the object, that will detect using sensor, and work only when the sunlight is available. Okay, and it is used for capturing the vegetation, soil, and water condition. So example of sensor use, that is optical sensor and thermal sensors. Then active remote sensing, which is use the artificial source, measure the reflected radiation coming from the source. So is for work for day and night. But passive remote sensing work for daytime only. So example is RADAR, radar, LIDAR, that is radar radio detection and ranging, and the LIDAR is the light detection and ranging. So if the rain is there or the cloud is there, in that condition also we will use the active remote sensing. Then next one is the based on the platform. There are two types are there. Based on a platform, there are three types: ground-based remote sensings. In the ground-based remote sensings, sensor is placed on the ground, like some tower will be there, like that, or the drone also. Then airborne remote sensing, we'll use the aircrafts or drone, which is sensor mounted and provide the high resolution images. And space borne remote sensing, where the satellites we use to collect the reflected radiations. Another that is based on the wavelength we use to identify the objects. For optical remote sensing, we'll use the visible, near infrared, and short wave infrared regions wavelengths used for vegetation, soil, and water studies. There are thermal remote sensing wavelength we use to measure the temperature mapping, soil moisture, and drought conditions. And the microwaves remotes U wavelength used for the clouds and work if they that condition if we want to detect the objects. So we will use the microwave remote sensing. So based on data, which types of data, the imaging remote sensing will be there and non-imaging remote sensing. Imaging remote sensing which produce the images like photographs and used in mapping and land use analysis. Where the non-imaging remote sensing which produce the numerical data instead of image and used for the meteorological studies. Then another type is the based on resolution. One is the spatial resolution, which is first to the size of the smallest object that can be detected. Used for them to know the size. The smaller the pixel size, the higher the resolution. 1 meter, 30 meter, 20 meter, 10 meter. So 1 meter will give the best resolution. So the example landslide will give 20 meter resolution, and Sentinel-2 will give 10 meter resolution. So smaller size will give the best resolution. So it will talk about the resolution. Then the spectral resolution, it will talk about the how the spectral we will separate, like the multiple spectral remote sensing and hyperspectral will be there. In that multiple spectral is the you will use the few band up to 2 to 10, and more than 10 up to 100 we will use the band that is hyper remote sensing. So this is the base remote sensing for the detailed information about soil and crops. There is spectral remote sensing. It is the number and the width of remote sensing remote wavelength bands the sensor can detect. So that one will use. So more the band, higher the remote spectral resolution. So in that we will see the distance. Hyperspectral will give the more spectral resolution compared to the multispectral. Then a temporal resolution. This is the data which is collected over the area for crop monitoring and seasonal study. Example models will use for the daily visit, and the land sensor used for the 16 days visit. Then a radiometric resolution is reports sensor ability to detect the slight difference in the spectra signatures. So these are the types of the remote sensing, and based on that we will select the one types to do the remote sensing for land use land planning or identification of the saline or salt affected area. So we'll see the what is the application of remote sensing. So which is used for crop acreage estimation or the area under different crops, or to monitor the crop health using the NDVI indexes. Also used for the yield prediction based on the crop condition. Used for the soil moisture assessment using the microwave remote sensing. For precision agriculture we can do for site specific nutrient management, and drought assessment, flood assessment also we can do. Then soil and land resource management, like mapping the soil, saline soil, erosion soil, salt affected soil, acidic soil. Then also used for land capability classification purpose also. Then for land use land cover also mapping and detection of degraded land, soil moisture variability mapping. They are also used for water resource management, like mapping of the groundwater, mapping of the surface water, then flood, then watershed management, and water quality assessment also. It is used in the forestry for forest cover management mapping, deforestation mapping, biomass estimation, wildlife habitat assessment, and biodiversity and conservation mapping. Then, what is the advantage of remote sensing? So, it can cover the vast and inaccessible area like forest, desert, and ocean in a single image. It will give the repetitive data like the satellite provide regular and continuous data which is used for monitoring the changes over the time regarding growth and deforestation. The semantic view we provide a broad and overall view of the area, help in better understanding of spatial relation. Then it will give the multi-spectral information like data available in different spectral band like VIS, NIR, help in accurate detection, identification of the object. Then it is a cost effective economics by a large survey. It will compare to the ground survey, useful for the inaccessible area. And digital soil accessibility will get easy integration with GIS and model for analysis. And most important, it will save the time because the data collection is quick compared to traditional method. The cost disadvantage is the high initial cost. So satellite sensor data processing in software is expensive. Required a skilled and technical person to analyze the data. And sometimes the atmospheric interference will be there due to cloud, dust, gas. So that time you will not get the correct data. So distortion will be the more in the data. Then limited spatial resolution, so we cannot detect small object or find details also we cannot find out. Data processing will be the complex, so all cannot do. So indirect measurement data is not direct, so require interpretation and chances of more error. And depends on the weather, remote sensing, the clarity or efficiency of data will get reduced. Then GIS. So what is GIS? GIS is a computer-based system which will use to collect, store, analyze, and manage or display the geographical data to support for decision making and problem solving. The father of GIS is Tomlin. We had developed the first geo information system in 1960 and worked on the Canada Geography Information System. For introduce, we have introduced the computerized spatial data analysis. In India, Madhav Gadwil is known as the father of GIS. What are the components of GIS? In that first will be the hardware, is a physical device which is used to run the GIS software. In their computers will be there, GPS devices we can add, scanner will be there, scanner, digitalizer and storage system. Software program will be there which is used to analyze the data like ArcGIS and QGIS, which is used for mapping and visualization analysis of data. Then a third component is data, means the most important component. We have two types of data: spatial data and attribute data. Spatial data like maps and images, and attribute data is like tables. So this is about our remote sensing and GIS. So how to use remote sensing and GIS for the detection of the land or land with land classification cover, or the mapping of the salt affected soil. That one we will see in the next video. Thank you for watching my video. Please like and subscribe my channel. Thank you.